All right, in this video, we're going to be looking at some of the different interactions of muscles and how muscles are named. Interactions being like what muscles do in a general sense, and naming just kind of things to help you understand the names of muscles. All right, so there's some general functional groups concerning muscles, but a couple other things before we talk about that. Muscles only ever pull, they cannot push. And so if you look at a muscle, it is pulling bones, it is not pushing them. So because of that, one muscle does something, the other muscle on the other side acts against it or undoes the thing that it does. And so because of that, there are a couple of terms associated with this. The prime mover is the muscle that is doing the thing. And so in this particular instance, if you're talking about forearm flexing, the bicep is the prime mover. The tricep is the antagonist. It does the opposite of that. Now, there are other muscles associated with forearm flexing, and those muscles are called synergists. They are helping the prime mover. They're adding extra force and stability. They're keeping your arm from doing things it shouldn't do. But the bicep would be the prime mover. The tricep would be the antagonist. Now, if you talk about forearm extension, where you're straightening your arm, then those roles are obviously reversed because the tricep is the prime mover in extension and the bicep would be the antagonist that's doing the opposite of that. And so just what do these words mean? Flexion, extension. And so we're going to talk about that too. Flexing means the definition here is crosses the anterior side of the joint. Don't really, I mean, that's helpful if you're into that. The way I think about it is it makes the angle smaller. And so if I'm talking about flexing my chest muscle, it causes my arm to move closer to my chest muscle. And so I'm flexing my whole arm in that way. If I want to do the opposite of that, if I want to extend my whole arm, then my back muscles, my lats are going to do that. And so that's moving my arm toward the posterior side of the joint or increasing that angle. These two words are also important, abduction and adduction. These are easy to remember. And again, you see this lateral, medial. If that helps you, by all means, do that. Lateral is toward the outside, medial is toward the inside. The way I have always helped myself to remember these is adduction is adding to my body. So when I'm adducting my arms are getting closer to the middle portion of my body. So I'm adding to my body. Abducting is moving it away or taking away from my body, if that helps. So we're going to use these four words, flexing, extending, abduction, adduction, a lot as we talk about muscles. So let's talk about some common conventions in naming muscles. I'm going to list 7 of them, I think, 7. All right, so one of those is where the bone or where the muscle is located in relationship to the bone. You see on the left, that muscle is attached to the temporal lobe or the temple of that muscle. And so that is the temporalis muscle. And so that's just based on its location. Another way that it can be named is according to its shape. The deltoid there, which is the shoulder muscle, is in the shape of a triangle, and which is the Greek letter for delta, and so that's why it's called the deltoid. A couple other things should be according to size, and so on the left you have the glutes, and there's the large glutes. That's why it's called the gluteus maximus, and on the right hand side you have the smaller glute. It is called the gluteus minimus, and in the middle you have the gluteus medius. So the words kind of make sense. All right, and it could have to do with the direction of the muscle fibers. This is really in the ab muscles here. You have the rectus abdominis, where it's located. Rectus means straight up and down. You have the obliques, which go at these diagonal directions. And then you have the transverse, which goes crossways. And so it tells you just by the direction of the muscle fibers, the name of that muscle. It could be named according to its origin. And so named like the sternocleidomastoid here, or the sternocleidomastoid is connected to the sternum. and the clavicle, and the mastoid process, and so you see that in there. It could also have to do with the action that the muscle takes, and so there could be extensors or flexors or abductors or adductors. And then another naming convention that I don't have a picture for. Actually, I could just go back to this picture here. Biceps and triceps are named because they have more than one origin. 2 origins for the biceps, 2 triceps have 3 origins, 3. So there's a couple naming conventions. Moving on, talk about lever systems. Because all muscles basically operate on a lever, there are 3 major components of any lever. Doesn't matter what sort of system or context you're looking in. Levers all have they have the lever, which is the bar here. They have the fulcrum, which is the moving point or the fixed point of movement on the lever. You have the load, which is the weight that is being bore by that. And then you have the effort, meaning that this is the direction that you're attempting to move this lever. And so if you can imagine like a pile of rocks on this thing, and you're trying to lift up this board, that fulcrum is the point of movement of that board. There are different kinds of levers that we use. They are, and before we talk about those different kinds of levers, we're going to talk about how some of them give you a mechanical advantage and some of them give you a mechanical disadvantage. And so the one on the left is going to give you a mechanical advantage. And the reason that it gives you a mechanical advantage is because the load is really close to the fulcrum. So the weight here is really close to the fulcrum. And so this long piece is used to move this really short piece. And so that is a very powerful movement. And so when the fulcrum and the load are really close to one another, that is powerful movement. This is a mechanical advantage. The other one is when the fulcrum and the load are further apart from one another, and the fulcrum's actually closer to the effort or the work. And so this creates a mechanical disadvantage. However, it creates a speed advantage. And so once this force is applied, this person's going to fly. Now, this never made sense to me, but when I learned about it in the context of like actual living things, it started to make sense to me. So we'll go to animals first because that's what I like. And so here's a mole. Think about a mole's whole life is about digging, right? This is its upper arm bone. This is its lower arm bone. And so the weight is going to be out here, or the load is going to be out here. The fulcrum is right there, really close. All right. And notice the upper arm connects like a portion of the way down on the lower arm. It's not like where we would connect right up here. And so this reduces that load and allows them to have a more powerful movement. The giraffe, on the other hand, notice what's going on here. The load is way out here, and here is the work is way back here, and here's the fulcrum. And so this is a speed lever. Giraffes are able to run really fast. Deer, other animals like them, and so this gives them a speed kind of thing. If you look at dogs or other sorts of animals, they have more of just even proportions. So they have a balance of speed and power, and you can kind of see that there. So there are 3 classes of levers found in, these are, again, general terms. We're going to talk about them in context of muscles. There are first class, second class, and third class levers, and it has to do where it's located, where the fulcrum is located. First class lever, the fulcrum is evenly placed between the load and the effort. The second class lever, the load is found in between the fulcrum and the lever. First class, the best way to think about this would be like scissors. I'll show you a picture in a second. It'll make sense. This would be more like a wheelbarrow. And a third class lever is where the effort is applied between the fulcrum and the load. And this is kind of like tweezers. And this is actually the representative of most skeletal muscles. And so I have a picture here to help with this. And so there's our first class lever. So there's the fulcrum, The load is the scissors are cutting. The effort is where you're putting it, and so there's an equal spacing there. And this would be examples of your head moving on your neck. All right, so your fulcrum is the connection between the neck and the head. The load is the head, either front or back, and then the muscles are tilting one way or the other. This second class is a great example. This is your foot, because the fulcrum is is where the toes touch. The load is the whole body coming down, but the effort is on the other side of that, pushing up. And so this is built for, this particular lever allows you to lift a lot of weight with a little bit of movement. And this one, the third class, you can see here the effort, where like tweezers, you'd put the effort here to hold the load. You can hold quite a bit with that, and the fulcrum being at the back. Most of your body systems are going to be in this way. If you think about this person lifting weights, the load is out at the end of their arm. The effort is their whole arm trying to come up, and the fulcrum point being the elbow. Most skeletal muscles are going to be in this third class.